In this video, we will discuss the pi bonding contributions in octahedral complexes for strong versus weak field ligands. I will assume that you're already familiar with molecular orbital theory and ligand field theory, but for some context, it is that we assume the metal complex is a spherical ball of positive charge that gets stabilized when electrons from the ligands, which acts as a Lewis base, comes to create a bond. Now, in ligand field theory, it takes crystal field theory and tries to rationalize it with molecular orbital theory. If you take a look at the top diagram, you might be able to tease out that the d orbitals of the metals might participate in pi bonding. Typically, pi bonding falls under two categories. They're called pi donor ligands or pi acceptor ligands. Pi donor ligands are with one or more lone pairs of electrons in the p orbitals that can donate freely into an empty orbital on the metal. An example would be chloride, bromide, iodide, or alkoxides. While pi acceptor ligands, they're typically ligands with an empty pi star orbital on the donor atom that can accept electrons from the metal. This is also known as pi back bonding. Examples could be carbon monoxide, nitric oxide, and cyanide. But if we take a look at the molecular orbital diagram, what would it look like? Well, all this diagram tells us is for all the sigma bonds only, these are the types of interaction. Now, for pi bonding, all we care about is the T2G subset, which could be figured out with the lengthy projection operator method. For pi donor ligands, they're the ones donating electron density into the T2G of the metal, which means that they start off with a lower energy to mix, and this creates a T2G and T2G star, with the EG star carrying over. And this has a much smaller octahedral splitting because the T2G star and the EG star is much smaller. While in the pi acceptor case, it is reversed. With the pi star orbital comes with the ligand, which mixes with the T2G of the metal and creates a lower T2G and a higher T2G star, and obviously with the EG star carrying over again. But this time we can see that there's a much greater splitting between the T2G and the EG star, which leads to a much higher octahedral splitting. In the pi donor example, since the splitting is small, we call this a weak field ligand, while the pi acceptor case, since the splitting is larger, we call this a strong field ligand. Now, if you take a look from left to right, you can see a trend of increase in the octahedral splitting. And this trend is what will be known as the spectrochemical series.